There is one common theme about everything, every single problem that you've seen so far, and you've seen this, you've seen in our math coffee, and that is critical thinking. Sophisms require critical thinking from you to be able to find the trick and actually see that the proof is tricking you into believing into absurd things. The next problem that Sebina is going to introduce challenges critical thinking of whoever wants to tackle it. It looks deceivingly simple, and anyone who's trained at using formulas would want to solve it immediately. But the correct solution actually takes time and takes a student stepping back a little bit and thinking about it and applying that critical thinking and looking critically at this seemingly simple problem. So Sebina this year surprised me by solving this problem, and that's one particular quality of hers is very strong critical thinking. Welcome, Sebina.
So when Ms. Slavina first described this problem to my class and I, like she said, we thought it was really simple. We just went at it, applied the formula, and that was it. But at the end of her explanation, she mentioned whoever solved this problem would receive a special prize. And that's when I knew that there was something to it and that I had to solve it. But that is not to say that I needed incentive to solve such problems. So in this problem, we have a right angle triangle with a base of 10 and the height of 6. We were asked to find the area of this right angle triangle. Now, what most of us did was apply the formula area is equal to base times height divided by 2. Now I applied what I knew about this right angle triangle into this formula. I got the area of 30. Now, looking back to my sketch, I just felt that something was fishy and the area of 30 was not right. So my next step was to apply the Pythagorean theorem to this right angle triangle. And the Pythagorean theorem is a squared plus b squared is equal to c squared. Next, I applied everything I knew about this right angle triangle to this formula. To do that, I assumed that the possibility of the measurements of these legs is 6 and 8. So 6 squared plus 8 squared is equal to 10 squared. And 36 plus 64 is equal to 100. Now, looking back to my sketch, I saw that the height and this leg were equal to 6. But the height of this right angle triangle is shorter than this leg. Therefore, it is not possible that the measurements of these two sides is 6 and 8. My next step was to apply Thales' theorem to this right angle triangle. So I inscribed it into a semicircle. Now I used what I knew about circles and applied it to my right angle triangle. For instance, I can split this, the base of this right angle triangle, which is the diameter, into 2 radii, which would equal 5 each. Now, my next step was from this vertex point to the center of this semicircle to draw another radius. The radius would equal 5. But the height of this right angle triangle is 6. Clearly, this height is shorter than the radius, but it has a greater value. Therefore, if a right angle triangle has a base of 10 and the height of 6, it cannot be a right angle triangle. Since it is not a right angle triangle, we cannot apply this formula, which assumes that the triangle is a triangle. And nor can we apply the Pythagorean theorem since it is not a right angle triangle. Therefore, this problem has no solution.